the resolution division as well as time scale. So let's talk about the CFL number. So essentially the CFL number is a lot about physics simulation. I think Blender just introduced this option in the latest update. So it's fairly new way of doing your modeling, and I don't want to get too into the concept and physics of it, because it will involve a lot of physics concept and mathematics, so I don't want to get too nerdy about it. But essentially you can sort of imagine, let me just get my brush here. You can sort of imagine we are inferring the movement of each of the particle inside of this system. You just imagine we got a lot of ball inside of this domain, okay? And because we got this initial sort of like a force field strength that push all this ball out, so you are going to calculate every ball 1 unit. So we got time, okay, so 0 and 1, so this will be a 1 unit of time. So we want to calculate the movement of ball, so 1, 2, 3, 4, and hit the ceiling, okay, and then we just coming out, something like that, okay. So basically that's how the simulation works. So the CFL condition, or CFL, is essentially a time step size, okay, and relative to the spatial or grid size, and you want to get a certain number. Sometimes we use mu for that, to add that sort of information ratio that we are moving the simulation. So essentially we got a step that you doing the estimation, okay. So basically you want that step to fit to your needs. So let me show you guys. So basically as a rule of thumb, CFL, if it's pretty high, which means that the step is pretty long, so you sort of imagine that the ball move from this place to this place, okay, and you don't care about what happens in between. So you even though say the ball moved to here and we got outside force, the ball should move to this place, okay, but you don't need to worry about that. You just say that ball start from here and end from here. But in fact, in reality, if you consider all these movements and outside forces, you might say the ball is actually here, right? And sorry about the noise, I just closed my window, okay? So actually the ball should move this way. This is a real world scenario, but in fact you are simulating this way, okay? So you are simulating the ball go to this place. So essentially if you got pretty high CFL, which means that the step is pretty long, so you don't actually represent the physics, okay. But of course there is also a good side of the CFL. So good side is that you do not need to consider this scenario, so you got quicker simulation, okay. So if you set the CFL pretty high, you might get some unforeseeable consequences. So for example, you got a certain block here and you want all this water or smoke coming here, and this should hit this surface and go this way and this way, but in fact because you infer that, you say that the step is pretty long, so you don't consider the blocker, so some of the particle may just move through this blocker, which is won't be happening in this real world. So you might see some of the mechanism that you device will fail in your simulation, but in fact you just need to change the CFL level. Okay, so and of course on the contrary, if you got the CFL level pretty small, and on the contrary you get a pretty accurate physics result. Okay, but that have a huge drawback, which means that you got spend a lot more time on the baking process. Okay, so I think that's pretty much it about the CFL. So let's go back to Blender. We already got this CFL number 4, and this is pretty good setting, so most of the time I don't change this at all. And if you are encountering some of the issue while you're doing the simulation, do remember to click this open. Okay, so use adaptive time series, and then you can adjust the time step maximum and minimum. Okay, maximum and minimum, you just sort of need to fine-tuning these two numbers in order to let your simulation make sense. Okay, so we don't have a specific guideline here. Okay, so as long as you already know this the logic behind that, because we're doing simulation, we're not doing a scientific study of a certain thing. Okay, so you can just simply eyeball it. So if you got a blocker here and the water should flow this way, not just trickling through, but sometimes trickling through is will happen in real life because we got some cracks on that. So you can get a small fine-tuning of tiny inaccurate results. Okay, so you need to fine-tune the maximum and minimum to fit your needs. Okay.